It's amazing that, this myth has sort of been propagated online that, if people eat a lot of protein, it's going to turn into dessert or, chocolate cake in the bloodstream. And so people really fear, eating a lot of protein. And so they tend to restrict protein and try to get it as low as possible so that they can get into the state of ketogenesis, where they're actively burning fat and generating ketones via the liver. But why is thinking of protein in this way maybe misleading?
Yeah, so many directions. I really never thought about protein as chocolate cake, but I really do like both of them. So that's a good idea. I like to think about protein in different levels. Clearly we have a minimum level that the body has to have. And as you get too high, the body really doesn't have any particular use for it. So, I think the problem in the keto world is, all protein has to get metabolized at some point. And the beauty of protein, unlike fat or carbohydrates, is it gets metabolized very slowly. And it also stimulates a lot of metabolism. So protein has a much higher thermogenic effect. It burns a lot more ATP just to metabolize it for reasons we can get into. So, I think that if you look at protein, the RDA is particularly low at around 8.8 grams per kg. I think that's way too low for everybody, and certainly for adults. So then the keto people start saying, well, at what level will it get you out of ketosis? My feeling is the sweet spot for protein is basically all adults should have protein at least of 1.2 grams per kg. That's kind of the minimum. So that puts people in a range of sort of 90 to 120 grams per day. And I think that's a very reasonable target. The lower end, obviously, for a smaller person, and the higher end for a bigger person. I think that's a totally legitimate area, and it won't disrupt metabolism. It maximizes muscle health and metabolism for muscle. So, I think it kind of in ranges. Clearly, if you're eating 300 grams of protein per day, you're going to be converting that into a lot of gluconeogenesis.
Right. So I know you've mentioned through your work, you found about 100 grams of protein turns into about 60 grams of glucose. Is that correct?
Yeah. So that seems to be the relationship. And that, again, it relates to the fact that there are 4 amino acids that are ketogenic, the branched-chain amino acids and lysines. They make up around 30% of the total protein. So, around 70% can get converted into glucose, and the body is a little inefficient with making protein into calories. So it turns out that for 100 grams, you get around 60 grams of glucose.
And making sure you get enough. So I know you mentioned that sort of around 2 to 3 grams of leucine is needed to trigger protein synthesis. For anyone who doesn't really understand what that process is, I guess you were saying about 30 grams of protein at a meal around 3 times per day would probably be a minimum amount to be able to trigger that muscle protein synthesis.
Okay, so what, and this is research direct from my lab, work by Tracy Anthony and Josh Anthony and Lane Norton and Gabe Wilson. This is research we did, really discovering the importance of a regulation in muscle known as mTOR. So mTOR is kind of a master regulator of protein metabolism in every tissue, but in muscle, it has a very specific role. In liver, which I mentioned earlier, liver protein synthesis is basically controlled by energy, not by protein. So that in the middle of the night, protein synthesis in the liver and the heart continue, because if they didn't continue, you die, okay? In muscle, it can be controlled differently. In muscle, muscle mTOR recognizes a variety of feedbacks. It recognizes hormones in the form of insulin or IGF-1. It recognizes protein, and interestingly, it specifically selected leucine as the thing in protein it recognized. That's kind of an interesting story. And it recognizes energy, ATP, through an enzyme or complex known as AMP kinase. So it's always integrating those three factors. When we're young, it's driven heavily by the hormone side. As we get older and no longer growing, the hormones really aren't our driving force anymore because we're not growing. So now it recognizes leucine. And so leucine is the trigger for that. What we have discovered is that to trigger that level, you need the intercellular level or blood level of leucine to go up about threefold. And to flood the body pool, to flood the blood with leucine, you need around 3 grams of leucine in the meal to do that. 3 grams of leucine, 2.5 to 3 grams of leucine. In general, in a mixed diet, most Americans get about 70% of their protein from animal sources and 30% from plant. And if you think that way, then a 30-gram protein meal will have about 8% leucine, and that gives you the 2.5. So where did the 30 grams come from? Well, it came from what does it take to get 2.5? You know, most people don't know what's 2.5 grams of leucine. So we said, well, it's 30 grams of protein. Okay, so that's where the number comes from. And that's the amount it takes to turn on the mTOR, which stimulates muscle protein synthesis. So that's a very long answer to where did those two numbers come from. The 30 grams, and the 30 grams, you know, if it's all whey protein, you can probably get along with 25 grams. If it's soy protein, you need 35. And so that's where the 30 comes from.
Right. Thank you.